All right, this is going to be the last video, last content for this semester. We're still looking at the method of shells to find the volume of rotated solids. Here we're looking at y equals x squared and y equals 2x, another region that we have seen before. So let's take a look at that. Y equals x squared, 1, 1, and then 2, 4. So we get our parabola. And then y equals 2x is just the straight line that goes through 0, 0, and also 2, 4. So the region we're talking about is this here, and we're rotating it about the y-axis this time. We did x-axis before. So we've got a quote-unquote solid that it doesn't look like a shot glass. I think it was kind of being a rose shape. It's got straight sides on the inside, curved sides on the outside. Very small volume we'll be looking for because it's a fairly thin little region that we're rotating about the axis. Remember, our setup is going to be 2 pi, the integral from where the region starts to where it ends. It's going to be 0 to 2 again. The distance that the rectangle is from the axis, which is x. And then the height of the rectangle. And this is the first one we've looked at like this. The height of the rectangle is not a single function this time. It's like back what we did in section 5.1 is going to be the function on the top minus the function on the bottom. So it's going to be 2x, the top curve, minus x squared, the bottom curve, dx. Okay? 2 pi, the radius, how far the cylinder is away from the axis of rotation, and then the height of the cylinder. I'm going to work this one out. These get a little tedious. 2x squared minus x cubed dx. Let's get 2 pi. The antiderivative there is going to be 2x cubed over 3 minus x to the 4th over 4 from 0 to 2. When we plug in the 2, we get 16 over 3, minus, that's going to be 16 over 4, which is just 4. Well, 4 written as over 3 would be 12 over 3, so that's going to be 4 over 3. So it reduces to 8, it doesn't reduce to, but simplifies to 8/3 pi. And that's a fairly small number. I think when we did it before, we ended up with something in the 4 pi range. This is fairly close to that. So I am happy with that result. This is another one of those that's too small for me to really be comfortable with an estimate or confident in an estimate. So I'm not going to bother with that this time. One more. Y equals cosine, y equals 0, and x equals 0 about the y-axis. So cosine starts at 1 and decreases to pi over 2. Not 2 pi over 2. At 0, it's 1. At pi over 2, it's 0. X equals 0 and y equals 0 are the x and y axis. And we're going to rotate that about the y-axis. So we're going to end up with a really squat bullet or helmet shape or whatever you want to think of that as. Think about your standard rectangle and how far it is away from the axis. 2 pi. Our original region starts at 0, ends up at pi over 2. X times cos of x. Our x for our distance, our cosine of x for the height of the rectangle, and then our dx. Approximation, or a guesstimate here, rather, for the size of this thing. I'm going to go to my alternate color. Say if I put a cylindrical box around that, the volume of that box is going to be pi times r squared. Our radius of the box would be pi over 2, so that's going to be pi squared over 4, times the height of the box is just 1. So our estimate is pi cubed over 4, which is about, pi cubed, a little more than 3. Well, pi is a little more than 3, so cube it, we'll get something a little more than 27. Say something about 30 over 4, and I think that's going to fill up about half of that box. So I'm looking for an answer somewhere in the neighborhood of 15/4, which is a little less than 4. We can't do this. You will learn to do this next semester. It's going to be called integration by parts when you do this. But for us, it's well out of our realm of expertise. So we're going to do this in the calculator. We'll just go x cosine x. Oops, I did something wrong. X cosine x and we're doing the second calc 7 from 0 to pi divided by 2. And that gives us that little shape, which is 0.57. So we have 2 pi times 0.57. Okay, we got our 2 pi from here. We just found the integral in the calculator. So if we multiply 2 times pi times 0.57, we end up with 3.5 or 3.6, give or take. And our estimate was 15 divided by 4, which was 3.75. So definitely close enough for me to be happy with that. Again, I ended up with 3.58-ish there. So that's my decimal approximation. And that is it for the semester. I think I will make one more of these to talk about the final exam. And of course, I'll see you in Google Meet if you show up. I wish I could say I've enjoyed the semester. I really enjoyed the first half of it. Take care. See you later.